Question 17, part B. Describe fully a single transformation that transforms triangle S onto triangle T. So describing is one of the more difficult things about translations because you have to figure out which transformation it is. So what has happened to shape S, this triangle, to transform it, to change it into shape T. So there are 4 types of transformations. Enlargements, so that means the shape gets bigger or smaller. Has this shape got bigger or smaller? 3 up, 3 here, 2 there, 2 there. No. So they're exactly the same size. So that means it's not an enlargement. So then we look at translation. Now a translation means just picking the shape up and moving it. So has the shape just been moved? So that would mean it would be still this. Here's my trusty tracing paper. It would be like this, but then moved over here. But that is not the same. So it hasn't been picked up and moved somewhere. So it is not a translation. Now a reflection is like we did in part A. There will be a line somewhere that the shape will have been reflected in. So that means if it was a straight line going down, it would have been reflected to look something like this. If it was a line going horizontally, then the shape would be reflected to look something like that as a diagonal line. So we can see that this shape has not been reflected, because if it had a horizontal line also, it would be reflected underneath. So a tracing paper is a really useful way of knowing where the shapes have been reflected. Horizontal line, vertical line. See how I'm making a vertical line with the tracing paper? This is how the shape would look. And then if it was a horizontal line again, a diagonal line, then it would look something like this. But that shape is nowhere near any of those. So it is not a reflection. So here you can use tracing paper to help. So fold horizontally, vertically and diagonally. Okay, so now we're left with a rotation. So that means the shape must have been turned. So we need 3 things with describing the transformation. So first of all, you need to say that it's the rotation, because we've now worked that out. You need to have the direction that you've turned the shape in, and the degrees. And then you need to have the coordinate. So, direction. That means I'm going to start by putting my tracing paper on the shape. So, first thing, trace the shape. Don't forget your arrow. So the arrow on here tells me which way the shape was facing up. Okay. Now, if I turn it clockwise, the arrow would be facing here at 90 degrees. The arrow would be facing down if I turned it clockwise 180 degrees, and the arrow would be facing in this direction if I turned it clockwise 270 degrees. Now, if I'd have turned the shape anti-clockwise, so that's the opposite way that your hands on your watch turn, so this way, your arrow would be facing this way at 90 degrees, this way at 180 degrees, and this way at 270 degrees. So the last thing you need to do is find the coordinate. So that is by placing your pencil on a point somewhere in between these two shapes. So I'm going to try and go right in between it here, and I'm going to keep my pencil. If I hold this with my left hand, just holding it tight, I can then turn the tracing paper and it stays in the original position when I bring it back. So now I've put my point here, and is there any way I can turn my shape? Arrow here? No, it's not. Arrow here, going down. No, it's not exactly on this shape. So that means, even when I put the arrow here and back to the same point, not at any time did it go on to this triangle T. So my point is in the wrong place. So if I am down here, they're in the right direction now, but I'm one square too high. I'm a couple of squares too high. I'm 3 squares too high there. So if we just try and move your dot just once at a time. So I was here, so just come down one at a time just to see what kind of difference it makes. So I'm left hand, if you're right-handed that is, if you're left-handed, put it in your right hand. Hold it tight so your paper doesn't move, and let's turn this arrow now. So nowhere near, still nowhere near. Now, I've actually come a bit closer to this now, so that means I'm going to try coming down once more. So back to the original. If I take my pen down one more, see what happens now. So now I'm too far to the left and still up 1. So if I come down this way, moving my pen again, back to the original. Did that in the wrong order then. So pen here, I wanted to try next. Now I need to see if it'll fit. I'm still out. So I need to come up 1 again. So up 1, put the triangle back on the original and try 0, 0. And then let's see if that fits. Now that fits perfectly onto my shape. So we now just need to figure out which direction we turned in. So if I turned anti-clockwise in this direction, my arrow is pointing this way. So I could have as my answer, if I can get the lid off my pen, rotation anti-clockwise. And which way is my arrow facing? This one is anti-clockwise. My arrow is facing this way, so that would have been a turn of 90 degrees. So I've got the direction, I've got the degrees, now I need the coordinate. I had my pen here at 0, 0. That can also be called the origin. So if you have either one of those, that would be fine. So what you'll now see is I can also turn it not anti-clockwise, but I could turn it clockwise. So if I turn it clockwise, again, that's perfect. So I could have rotation clockwise. And clockwise, if my arrow is facing this way, I've turned 270 degrees. And then my coordinate was 0, 0, or about the origin. Either one of those will give you 3 marks. So if you have all 4 of these options, 1, 2, 3, 4, or 1, 2, 3, 4, that's 3 marks. For 2 marks, you can have any 2 of them. So you could have said this one and this one, or this one and this one, or this one and this one for 2 marks. So 2 marks. Any 3, 1 mark, any 2. So for 3 marks all 4, 2 marks any 3, 1 mark any 2.